Swayam Prabha. Digital India. Educated India.
Welcome back. Another example where usually we will not expect that any slip will take place because the slope is very gentle and the material which is sitting on the surface is an hard rock. Now this is an example where you see that you are having a very fine grained rock and then you are having a limestone here. So if you look at the top only and then you will say no, only this area will never have a landslip. But the shale, we discussed in one of the lecture that this will act as a slippery surface or the plane of weakness which can result into the landslip. So if this gets water saturated, that is shale, it will allow the material to slip down and result into the formation of extensional crack in the hard rock which is sitting or overlying this softer rock mass. So rock spreads are defined as blocks or slabs of bedrock that moves laterally without a well defined basal shear plane or the shear surface. Lateral spreading has also been another term which has been given to this, which may develop in finer unconsolidated sediments like clay, silt and sand, mainly the finer material. It is mainly due to the increase in pore water pressure at a relative shallow depth. So even if you are having near surface this material and a very gentle slope, you can experience lateral spreading. So rock spread and lateral spread, this is a typical example which we encountered during 2001 Bhuj earthquake, and this is basically because of the lateral spreading, where along a very gentle slope, if you look at here, what you can see is in very flat area, but overall regionally if you take the profile, we took the topographic profile, we found that this area is sloping towards south. So this was north and this is south, so it was sloping towards north. This is your south and this side is north. So this we encountered or observed the deformation which resulted into the lateral spread. There is another example of the same. We are having the photograph is taken looking towards south. So these steps which you see is because of the extensional cracks which were developed, and this is a typical example of lateral spreading. And this was because of the increase in pore water pressure because of seismic shaking. And this is an example of 2001 Bhuj earthquake in epicentral area. Very important, and of course sometime beneficial, and must have also have the disadvantages. So suppose you are having a very steep banks along a valley. If there is a movement of the material or the landslide and the material getting into the valley, this will result into the formation of natural dam. So what you see here is the formation of lake, and this is a very common phenomena which one can come across in the hilly terrain like Himalayas, where we see at some locations the lake deposits, and those lakes are formed because of the massive landslide, the material sliding into the river bed or a valley, blocking the flow of the channel, resulting in the formation of lake. But when this gets breached, then you will have flooding events in the nearby area. So we also say landslide dam, and this is an example of the typical lake formation along the valley because of the landslide blocking the flow of the river. Then we have, this is an example we have already discussed, the slumps and the rotational slide, very good example. Another one from Himalayas. Now if you see here, what this is a river bed here, and the road which has been constructed is on the top of the river bed. Just they have filled up this portion here and constructed a concrete road. Now there is an undercutting or erosion which will keep on taking place, because if you are not having the overflow from the top, but the water will keep on seeping from below. Again, no foundation was been given here, as the construction was been done, putting the material or filling the material and putting the concrete road on the top. And most of the time what we find is that such roads which are been constructed connecting the either banks will be eroded very quickly. So they may last for a couple of seasons, and then again you will have to do the reconstruction of such roads for transportation. So another good example from Dehradun region, what we see here is the channel which is flowing in this region and a bridge over here. The problems which are being faced is that every time there is an excess amount of sediment bed load coming during the floods and covering this the bridge, it can damage this, because this is the only connecting bridge at that point of time. This photograph was probably taken during 1970s, which used to go to Mussoorie. And the backdrop what you see is the lighter scars. These are all the landslide scars, and there is a main boundary thrust, the fault system, major fault system which is active fault system in Himalaya, is passing through this region. So the ongoing deformation along this main boundary thrust is also responsible in churning the material here and acting as a source of the loose material for this channel bed load. So every time what they do is they clean up this portion, that is an arc area here, to facilitate the water to flow through as early as possible. So dredging has been done continuously before the rainy season. To protect this arc, what they did was they constructed the retaining wall here, which has been shown with this white patch. I'll show another photograph, to stop the material getting into this region and damaging, because if you are having the material which gets filled up here, the channel cross section area will decrease and the water will start flowing on top of this road. So this photograph has been taken looking downstream from the upstream part. The previous photograph is from the downstream looking upstream. So, now what we see is that after few years, with an understanding that this is getting filled up, they put a retaining wall somewhere over here, which you see in the next photograph. But what happened again? Similar to what the road was been built on a river bed connecting both the banks. So, this is a retaining wall, and as I was talking about the road which was been constructed connecting the banks on either side. Again, in the similar way, this retaining wall was been put on the river bed without having proper foundation. So, to allow the water which has been seeped within the sediments here, there are some outlets which have been put here, but those were not enough. So, this photograph we took when we took the 2001-2002 civil engineering badge to this area. The landslide which I was showing in the previous slide is your Kalagar landslide. So, what happened after that? So, students are sitting on the retaining wall on Kalagar Nala, Rajpur near Dehradun. After few years, this what happened. Okay. So, this is another example which we can say that this is because of the seepage which broke the wall underneath, but the top wall remain as it is. So, this is another example of the landslip or the erosion which take place within the river valley. So, the landslip took almost like a week. This is a movie from US which shows the mass movement, and you can see the top scars which have been developing here, the extensional cracks, and the mass which is moving down here in the toe is under deformation. Another good example from Pinjore area. This is around 25 kilometers from Chandigarh. So, this is in Pinjore Doon valley. Example is from this region which is known as Kalka. So, this photograph was been taken long back in 1978 by Professor Nakata, and what you see here is one is the rail track here which goes to Shimla. This is the same rail track which goes to Shimla here, and then we are having we took another photograph, and there is an active fault here, but I am not going to talk about the active fault in this one. Okay. There is another photograph which I took in 2000. So, if you want to have the similarity, this peak and this peak is the same. The rail track, of course, the angle is different, but the rail track you can see here, lot many big trees have come up, but what we are able to see is that no population here, no population here, and slowly, if you carefully see, there are a lot of houses which has come up. Okay. So, close up of that again. So, this portion which you see here, all terraces are been occupied by the settlement. Now, whenever there is a peak flood in this region, this whole area will get affected. So, river bank erosion, undercutting of the banks, definitely this fellow will be drowned very soon, and this must have happened up by now, because those photographs will be taken almost 7 to 8 years back. Coming to fall, the rock fall are defined as free falling fragments of rocks or the blocks from the steep cliff or slope usually occur along an undercut stream or bank or an eroding valley walls. Movement is sudden or rapid. Weakness do occur along the bedding planes or joints in the hard rocks. In high altitude regions, this will take place because of freezing and thaw effect. Again, movement of rock blocks, landslip again, and this was in Bangladesh, which was triggered because of torrential rain. Landslide in Uttarakhand, again because of the undercutting of the river bank. So this is an animation which was been given for Uttarakhand, which blocked the channel because of the landslide. So landslide in steep hard rock terrain mainly depends on the orientation and nature of discontinuities present, and this discontinuities could be either joints, bedding planes, etc. Now in general, the geological structures that can influence the mass wasting is what we have discussed in part, that is weakness, plane of weakness in rocks, either or plane of weakness, maybe one is bedding plane in the sedimentary rocks or the foliation, for example, in the metamorphic rocks. So another example of subsidence, it represents the downward movement of the surface. It may occur because of the plastic outflow of very fine material, most possibly the clay or silt, and so it occurs when a plastic layer, that is mainly the clay bed, is squeezed outward due to the overlying heavy load. The example of 1964, this was been triggered because of the Alaskan earthquake, where the clay bed, which was sitting in the deeper portion capped by gravel succession, squeezed because of the strong ground shaking. Subsidence can also occur due to collapse, and it occurs due to the extensive pulling out of a large volume of underground water, or due to subsurface solution activity, is mainly in the limestone terrains where we see typical formation of potholes. So typical of the limestone terrain and subdued topography, but in between what you see here is the depressions, and these depressions are because of the dissolution activity taking place subsurface. Another example is your excess removal of groundwater can also result into the subsidence. Now this example, what has been shown here, so we have a ground surface here, a vadose zone and a zone of saturation, and then bedrock. So if you keep on removing excess water from this region, which has been pumped out here, then the pore space which were earlier been filled by, or this zone of saturation, the pore space filled by water will go into compaction. So this is in compacted sediments, and that will result into the the increase of this Vadose zone and the decrease of the saturation zone. Here, this compaction and the increase in the Vadose zone, because of the excess removal of the water from this unit, will result into subsidence. This is an example from the because of the subsidence in the limestone terrain, where you can see the potholes because of the dissolution activity. It's another example from the same. You can see the size of the potholes, where you can compare with the dimension of the cars here. You can understand what is the magnitude of that. So this is because of the dissolution activity. The another one is excess removal of water. The best example is Leaning Tower of Pisa in Italy. So we will discuss this control and stabilization portion in the next class. Thank you so much.